So grade 6, I told you, you people are candidates, and we have you at heart. We are doing all this to make you have easy time of revising at home, of learning at the comfort of your zone. Don't take this thing for granted. Don't take these lessons for granted. Whatever I'm giving you, the content I'm giving you here, I cannot be that mad to give a wrong information in the whole world, because remember, this thing is watched worldwide. So the content I'm giving here, be very careful. Pay attention to every bit. If you can watch these videos as many as possible, the better. Because the reason why I came up with this online thing, most of our learners nowadays, especially those who are in the urban areas, they are really used to the digital devices. So finding them reading books sometimes is a problem. So they prefer these digital devices than taking a book and reading it physically. So that is why I came up with this, so that your digital device, which you love so much, as you use it, log into check whatever I posted in the channel, watch it, give it around some 30 minutes, 20 minutes, then get some information from there. It might help you by the end of the day. Otherwise, we are discussing science and technology, grade 6, under the substrand, human circulatory system, a substrand that has really given most learners headache. As a substance that has really given most learners headache. Most. In a class of 30, if this thing is taught, if not 15 of them, then more than 15 will still have a problem. I have experience of the same. I have experienced the same. I have taught so many learners, but I realized that there was a misunderstanding, the concept, because this thing is a very small thing. But if it is not explained well, then the pupil gets confused, or the learner gets confused. So I came up with a way of simplifying it, so that from the word go, just looking at maybe a diagram, you have all the information there. You have all the information there. So I have decided to simplify it, and it has worked. I have really helped so many learners now understand the concept of human circulatory system. Now, under this substance, in our body, there are what we call activities that take place. So if you watch my grade 4, Science and Technology, digestive system, that word system is also used in grade 4, digestive system. In grade 5, breathing system. In grade 6, circulatory system. So this word system means an activity that takes place in different parts. So it is an activity that for it to take place, different parts are involved. That's why it is called a system. It moves from this part to this part to this part to that part. So there are a number of parts that are involved. That forms a system. So any system you see, either digestive system, you look at the digestive system, there are so many parts involved in that system. You look at breathing system, there are so many parts involved. Same to this human circulatory system. It is a system, there are so many parts that are involved. So that is what we want to check. What is this circulatory system? Now, circulatory comes from the word circulate. Circulate means to go round. Going around, coming back, going around, coming back. That is, you are circulating. Sometimes they say you are circulating a wrong information. That means you are spreading wrong information. You are circulating an information. So to circulate means simply means going round, coming back, going again. That is where this word is borrowed. Circulatory system. So what circulates in our body is majorly the blood. So the blood moves in our bodies throughout the body. So that movement from this part to this part, back to this part, to that part again, back to that part, that is what is called circulatory system. The movement of blood in our body is what is called circulatory system. So circulatory system helps in the movement of blood in the human body. Now, because it is a system, it is made up of certain parts. So we talk about the main parts involved in the human circulatory system. Main parts. I'm calling them main parts because those are the parts that are directly involved in this process or in this system. Main parts of the human circulatory system. Now, these parts are very few. These are very few parts. In fact, there are only three. There are only three. Apart from that, there's none. If you add another one, the fourth one, that one is yours. There are only three parts that are involved here. The first part is what we call the heart. Does a very important role in this process of circulating blood in our body. That is the first part. The second part is the blood itself. That is what is supposed to be transported or to be circulated in the body. So that is also one major part of this system. Then the last part are what we call the blood vessels. The blood vessels. Now, these blood vessels are what are responsible for taking blood from this point to another. We used to call them pipes in our bodies. It is just a pipe where the blood follows. The blood does not just move like an ocean. You know, sometimes you go to the coastal region and the ocean sometimes move certain distance, then comes back without following any channel or any tunnel. So the blood does not work like that. The blood needs a pipe to take it from this point to that point. So those pipes are what we call blood vessels. So we call them pipes in the body. So by a short definition of this thing in bracket, if you want to know what they are, the heart is what pumps the blood in the body. The heart is what pumps this blood. So heart in this system, it is a pump. The blood in this system, it is the water or the liquid to be pumped or to be supplied. Then these are what we call by the pipes through which that water should be transported from point A to point B. Now, after knowing these parts, what follows immediately are parts of the heart and their function. And that is where the problem comes. Once you understand the parts of the heart and their functions, you are done with the whole process. Now, I will sketch how blackboard is small. So I have to rub this. If you have a notebook, you can note them, but I will have to rub them so that I have a diagram of the heart here. We look at the parts, then maybe functions if we can. Now let me have the parts of the heart. Parts of the heart and their functions. Parts of the heart. Parts of the heart. So we are going to sketch. You don't laugh at my diagram. By the end of the day, if the message is at home, you are good to go. So let me have my heart here. I will draw something like this. Something like this. It's a very simple diagram. We don't need a very complicated science. We don't draw very complicated diagrams. This is not a creative arts where you draw and shade. We only need a simple structure. You know that to call it a structure or what. Art is divided into two, so we will use that line. So from my drawing, I want to show you some parts here that you have to be very keen about. So the heart is divided into two. This side then it is also divided into chambers. Chambers of the heart are 4. So we have, this is the first chamber, the second chamber, the third chamber, and the fourth chamber. So in general, the heart has 4 chambers, or the heart is divided into 4 chambers, but into 2 parts, the right and the left. So those are different things. The heart is divided into 2 parts, the right and the left, but it is divided into 4 chambers. 2 chambers at the upper part, 2 chambers at the downer part. So this is our heart, even if it is as ugly as that. Now after drawing parts, we want to name them, naming the parts. So this part is called the vena cava. The vena cava, that is the first part on the right, on my left hand side. Then from the vena cava, you go to that up the next part. That next part is called pulmonary artery. Pulmonary artery. That is this part here. Then from the pulmonary artery, you move to aorta. Aorta. Then there is another pulmonary here. Pulmonary vein. Now these are what we call the blood vessels. These ones. But those are big pipes. They're big pipes. These are what brings the blood in the heart and takes away the blood. So those are the pipes. Vena cava, pulmonary artery, the aorta, and pulmonary vein. When you come to inside the chambers, the upper parts are called auricles. And because one is on the right and another one is on the left, so the auricle that is on the left is called left auricle. The auricle that is on the right is called right auricle. So how do you identify the right and the left? That also has become a problem. Now, if you have the heart like this, anytime you have a diagram drawn in front of you, I want to take, for example, this one. If I'm facing this diagram like this, it's like somebody is standing in front of me, facing me. So if you are standing in front of me and you are facing me, and I'm also facing you, we are facing each other, my right hand side is your left hand side. My left hand side is your right hand side. That is the first way of identifying where the left side and the right side of this heart is. So if I have this diagram in front of me like this, it's like somebody is standing in front of me and we are facing each other, and therefore my right is the left side of this person. So this side is the left side. This side is left. And this side, my left, is the right side of this heart. That is one simple way of identifying the right side and the left side of the heart. Number two, let us now name them. So I've said because this side is on the right, this one is called right auricle. This one is on the left, so it is called left auricle. Left auricle. Those are upper chambers, they are called auricles. Downer chambers are called ventricles. Ventricles. So the one on the right is called right ventricle. The one on the left is left ventricle. As simple as that. So you are done with the parts of the heart. What is remaining is their functions, which we are not going to write anything. We are going to use this diagram the way it is. I said I have simplified this thing. Just this diagram alone is enough for you to understand the whole process of human circulatory system. Now, they talk about the functions of these parts. So we are going to start with the first part here, which we wrote, the vena cava. Now, this vena cava is the pipe that the blood follows from the body coming into the heart. So you will draw an arrow like this. That arrow shows that this is blood that is coming from the body. So once you draw this arrow, you write it from the body. That means the blood from our bodies going back to the heart will get into the heart through the vena cava. Through the vena cava. The blood from the heart, the blood from the body will get into the heart through the vena cava. That is the first part. The second part we said pulmonary artery. Now pulmonary artery, I want you to look at this. Now this blood, once the vena cava has brought it here, there is this part where it is coming to, the auricles. The work of the auricles, both left and right, is to receive blood. You can note that one somewhere. The work of the auricles is to receive blood. And because there are two, one is receiving blood from the body, another one is receiving blood from the heart. So this one, because vena cava brings blood from the body, the right auricle will receive blood from the body. That is the work of that auricle. So the work of the auricle, right auricle, is to receive the blood from the body. Then once that blood has been received by the auricle here, the auricle passes it down to the ventricle. Why must it go to the ventricle? Because when we were starting, I wrote that the work of the heart is to pump. That pumping takes place at the ventricles, upper and here. Both ventricles does the work of pumping. So the blood must come down here so that it can be pumped. So I want you to look at the flow of blood, how it is flowing. So the blood has come from the body through the vena cava. It has been received by the right auricle. The right auricle passes it down to the right ventricle. The right ventricles, that is the place where pumping is taking place. So the right ventricle pumps it. Let me rub this part here. Pumps it to. So I want you to draw this arrow also here. That means that blood is going out to the lungs. So this one you write to lungs. So this one is from body to lungs. It is the same blood. It is the same blood. The blood that has come from the body has been received by the right auricle. The right auricle passes it to the right ventricle so that the ventricle can pump it to the heart. So it is going to the heart, and therefore the whole of this right part of the heart carries what we call deoxygenated blood. Deoxygenated blood means the blood that has oxygen has been used up. That's why it is coming from the body. So it is coming from the body because it has been deoxygenated. The oxygen has been used. So it must come back to the heart so that the heart can take it to the lungs to be given oxygen. Once it has received that oxygen, it comes back to the heart. Then the heart can pump it to all parts of the body. So there is that flow. So we are here. The blood has gone to the lungs somewhere up there. So the lungs will give this blood oxygen. Once that blood has received that oxygen, the name changes from deoxygenated to oxygenated. So it becomes an oxygenated blood. So that blood comes back to the heart. So it will come like this, back to the heart through the pulmonary vein. So this one you will write from the lungs. That means that blood has come from the lungs. Why is it not going directly from the lungs? Because now it has oxygen, it should be used in the body. Why is it not going directly from the lungs to the body? The lungs cannot pump. So it must come back to the heart so that the heart can pump it to all parts of the body. Remember this, there must be pumping. It's like you want to supply water in the house. You have different rooms. That water cannot go into those rooms if you don't have a pump. So you need a pump to pump that water to the kitchen, to the garden, to the other house. So you need a pump, in short. So that pump is what this heart is doing. That for that blood to reach my head, my toe, my hands, and all over, it must be pumped. So that's why it can't go directly from the lungs to all parts of the body, because the lungs does not pump. What pumps is the heart. So it must come here. So look at the flow again. It comes from the lungs, gets in through the pulmonary vein. Then it is received. I say the work of the auricles is to receive. So the left auricle now receives that blood from the lungs. The work of the auricle, that left auricle, to receive blood from the lungs. So it will be received here, and it will do the same thing. It will pass it to the left ventricle. Why? Because pumping can only be done at the ventricles. So the work of the ventricle is to pump. The work of the auricles is to receive. So the left ventricle will pump it to all parts of the body through the aorta. So you can write there to the body. To the body. Once you understand that flow, you are good to go. So you realize that we have this outer blood vessels, this outer one, the vena cava and the pulmonary vein. The outer blood vessels brings blood into the heart, brings in. So I'm trying to simplify this thing so that you don't read so many books and this thing is not getting. So look at the outer blood vessels, the vena cava and the pulmonary vein. They bring blood inside the heart. Then the inner blood vessels takes them out. So this one is taking to the lungs, this one is taking to the body. So that's why I said by just looking at this diagram, you can understand the whole process. I have just said that because this blood has come from the body and it is the same blood being received in the right auricle, being passed to the same right ventricle and pumped to the lungs, this side of the heart carries deoxygenated blood. So the right side of the heart carries deoxygenated blood. This is blood from the body that is coming to be pumped to the lungs. Once it has reached the lungs, it is being given oxygen. It is being oxidized. Once it has been oxygenated, it comes back. Now, it is now with oxygen. This blood here from the lungs has oxygen, so it is called oxygenated blood. The same oxygenated blood is being received by the left auricle. The left auricle passes it down to the left ventricle. The left ventricle pumps it to the all parts of the body through the aorta so that it can be used. Once it has been used, it comes back again through the vena cava, then goes back to the lungs, comes back to the heart, goes back. So that is what is called circulation. It circulates the body, the heart, the lungs, the body, the heart, the lungs, the body, the heart, the lungs. That is the circulatory system we are talking about here. Now, this diagram gives you a simple way of understanding the human circulatory system. The last part I want to talk about are these two parts here. If you look at down here, this part is drawn, it's smaller than this one. So these ones are called thick walls of the ventricles, walls of the ventricles. So sometimes you can be asked, why is the wall of the right ventricle thinner than the wall of the left ventricle? Or why is the wall of the left ventricle thicker than the wall of the right ventricle? This is the reason. Now remember, pumping is done at the ventricle. Both of them does the work of pumping. Now if you look at the right ventricle, where does it pump blood? To the lungs only. Only in one place, only to one place, the lungs only. But if you look at the left ventricle, it pumps blood to all parts of the body. So just like the real life experience, if you have a big home and you want to supply water through pumping in that whole big home, there is a type of pump you are supposed to buy. A small pump can only pump water to a small distance or a shorter distance. A big pump will pump it to all parts of the body. So because of that, this one pumps blood that has a lot of pressure. The pumping here has a lot of pressure because that blood goes to all parts of the body. So there is a lot of pressure on the left ventricle compared to the right ventricle. So because of that pressure, the walls of that left ventricle must be thick to withstand that pressure. The walls of the left ventricle must be thick so that it can't burst because of that pressure. Just like in our country, initially, when I was young, I used to see the water pipes. The water pipes, there was a lot of bursting water pipes all over because the type of pipes that were used by then were these small black pipes. Nowadays, those pipes are used for carrying out the electrification in the house, doing wiring in the house. But initially, those ones were the pipes that were used to supply water in different. So these pipes used to burst. You reach this after around 10 meters, water pipe has bursted there. You move another 20 meters. So there was a lot of burst because the pipe that was used by then was of low quality and the pressure is high. So that's what happens here. If the pressure is high, this thing can easily burst if it doesn't have a thick wall. So that is why Kenya came up with this green pipe. This green pipe is a very hard pipe. So nowadays, water insulation is done using that green pipe. It is a pipe that has been modified to withstand that pressure. So nowadays, getting that a pipe as busted, the water is coming out, is very difficult. Unless maybe there was some construction and somebody has interfered with it. So that is what happens. When the pressure is high, you look for a harder casing or a thick casing that can withstand that pressure. So that is what happens here. The left ventricle, being that it pumps blood to all parts of the body and has a lot of pressure. So because of that high pressure, the walls must be thicker than the right ventricle, which only pumps it to one place, only the lungs. Up to there, I think I have really tried to simplify these things. Though there are some small areas that maybe we will check when we are revising something like that. Otherwise, as always, if you have a question, you have a comment, put it in the comment section. Subscribe if you have not, share and like. Thank you for watching. Let's meet again.